Welcome to The Explainer. Today, we are talking about the remarkable story of our universe. It's a theory that explains just about everything we see, from a single fiery beginning to the vast cosmic web of today. And honestly, it's a stunning scientific success story, but it might also be on the verge of a huge crisis. For most of human history, this question, did the universe have a beginning, was really one for philosophy or maybe religion. But over the last century, science has actually found an answer. And it all started with a simple but absolutely profound observation of the night sky. So let's start with the beautiful foundation of modern cosmology. It's a story that was built on the incredible work of some brilliant astronomers and, well, a physicist you might have heard of named Albert Einstein. Okay, so picture this. It's 1929. Edwin Hubble and his assistant Milton Humason discover something that completely changes everything. The universe wasn't just sitting there, static. No, distant galaxies are actually rushing away from us. And the crazier part? The farther away they are, the faster they're going. Now, this doesn't mean we're at the center of some big explosion. What it means is that the very fabric of space itself is expanding, and it's carrying all these galaxies along for the ride. So how in the world did they figure that out? How do you measure distances that big? Well, to do it, astronomers needed what they call standard candles, something with a known brightness. And they found them in these amazing stars called Cepheid variables, which pulse in a really predictable way. They became the cosmic yardsticks that let us finally measure the true scale of the universe and how fast it was expanding. And this, right here, leads to a conclusion you just can't avoid. If you run the cosmic movie in reverse, if you rewind all of that expansion, then everything, all the galaxies, all that space, it all has to rush back together. It all converges to a single, infinitesimally small point of unimaginable heat and density. A fiery beginning about 14 billion years ago, the Big Bang. But, this simple, really elegant picture, what scientists called the Einstein de Sitter model, it had some major problems. When the theorists tried to actually build our universe using just this basic idea of matter and expansion, well, the numbers just didn't add up. The story was missing some crucial pieces. There were three huge puzzles. First off, where did galaxies even come from? Say, if the early universe was perfectly smooth, gravity would pull equally in every direction. Nothing would ever clump together. It'd be like trying to build a sandcastle on a perfectly flat table that's constantly vibrating. Second, the conditions for our universe to even exist in the first place had to be fine-tuned to an absolutely impossible degree. And third, when astronomers added up all the matter they could actually see, it wasn't even close to being enough to make the theory work. In fact, all the stuff in all the stars, galaxies, and dust clouds we can see with our best telescopes, it only added up to about 5% of what the theory said should be there. So the big question became, where was the other 95% of the universe? To solve these incredibly deep puzzles, scientists came up with three really radical new ideas. And these weren't just minor adjustments. They were huge, revolutionary additions that basically transformed the simple Big Bang theory into the complex and, let's be honest, kind of strange, standard model of cosmology that we have today. The first fix is called cosmic inflation. The idea here is that in the very first fraction of a second of its existence, the universe went through this insane, violent burst of expansion. It basically hammered space flat and took tiny, random quantum fluctuations and blew them up to cosmic size. And those became the seeds from which every structure we see today, including our own galaxy, would eventually grow. And the most amazing part? We can actually see the evidence for this. This map here shows the cosmic microwave background. It's literally the afterglow of the Big Bang, the oldest light in the entire universe. And those tiny little variations in temperature, the blue and red spots, those are the imprints of those ancient seeds, frozen in time for us to see. This ancient light was the smoking gun. It gave us the crucial proof we needed. As one scientist famously put it, finding these specific patterns was like finding a bloody thumbprint at a cosmic crime scene. It totally confirmed the predictions of inflation and told us that our very existence is thanks to these tiny ancient quantum jitters. Okay, the second fix was a mysterious, totally invisible substance called dark matter. It was actually first proposed way back in the 1930s. This stuff provides the extra gravitational pull that was needed to form galaxies in the first place, and it's what keeps them from flying apart today. You can think of it like a huge, unseen scaffolding that holds the visible universe together. The third and by far the most shocking fix came in the late 1990s. Astronomers discovered that the universe's expansion isn't slowing down because of gravity, which is what everyone expected. No, it's actually speeding up. The only way to explain that was to propose a dark energy, some mysterious force inherent to space itself that's pushing everything apart. And the irony is, this brought back a cosmological constant that Einstein himself had once called his biggest blunder. Turns out he might have been right the first time. So here's the crucial point. After applying all these patches, we get our modern picture of the universe. And honestly, it's pretty humbling. The ordinary matter, the stuff that makes up you, me, the planets, the stars, everything we've ever seen or touched is only about 5% of the total. The rest is made up of dark matter and dark energy. Things we can't see, and fundamentally, just don't understand. Now, for a good while, this new and improved theory, which scientists call the lambda CDM model, it seemed incredibly solid. It just explained so much so well. But now, as our measurements get more and more precise, new cracks are starting to show up in this grand foundation. The biggest problem right now is something they call the Hubble tension. Here's the deal. When we use our model of the early universe, that cosmic microwave background, to predict how fast the universe should be expanding today, we get one number. But when we go out and directly measure the expansion rate using nearby stars, we get a different number, a faster number. And the two methods just don't agree. And this gap, it's not going away. And it doesn't stop there. The incredible James Webb Space Telescope is now peering back to the dawn of time, and it's finding massive, fully formed galaxies that, according to our theories, just shouldn't exist so early. Our models say galaxy formation should be this slow, gradual process, but Webb is showing us cosmic teenagers where we expected to see, at best, cosmic infants. So, what does this all mean? We have this powerful theory that has absolutely dominated cosmology for decades, but now it's being stretched to its breaking point by our own better observations. And this has led some scientists to ask a really tough question. Are we just patching up a fundamentally flawed theory by constantly inventing new invisible things like dark matter and dark energy? As a group of cosmologists wrote a while back, in pretty much any other field of physics, doing this over and over would raise some really serious doubts about the core theory itself. And this right here is a beautiful illustration of how science actually works. The Big Bang Theory is without a doubt our best explanation for the universe, and it's backed up by mountains of evidence. And yet, at the very same time, it is profoundly incomplete. It's a grand story with entire chapters that are still missing. And maybe that's the most important lesson in all of this. The quest to understand where we come from is so far from over. As Einstein himself knew, today's scientific truth can easily become tomorrow's puzzle. The story of our universe is still being written, and there are undoubtedly more surprises waiting for us out there.